this video, I want to cover all of the main concepts and definitions within the context of functions. Now, be advised that there are many definitions and concepts within the context of functions, but hopefully this video can clear up everything and wrap everything together. All right, let's get started. A function is a rule that assigns each element of a set called the domain to exactly one element of a second set called the codomain. Now, it's important to understand that the codomain and the range are not the same thing. The range is a subset of the codomain. So the codomain doesn't include necessarily all of the elements that are in the range of the function. It might include more elements. All right, so here's some notation. f:(x arrow y) is our way of saying that the function is called f, the domain is the set x, and the codomain is the set y. And it's important to understand that we say f sends x to y. All right, next, to specify the rule for a function with a small domain, use two-line notation by writing a matrix with each output directly below its corresponding input, as in f equals 1 sends to 2, 1 goes to 2, 2 goes to 1, 3 goes to 3, and 4 goes to 1. This is a very uncommon way of writing function notation, but this is a sort of function notation. All right, next up, f of x equals y means that the element x of a domain is assigned to the element y of the codomain. We say that y is an output. Alternatively, we can call y the image of x under f. The range is a subset of the codomain. It is the set of all elements which are assigned to at least one element of the domain by the function. That is, the range is a set of all outputs. So again, there's a slight difference between the range and the codomain. The codomain is the large picture where the range fits inside of. A function is injective, an injection or one-to-one, which you might be more familiar with, if every element of a codomain is the image of at most one element from the domain. A function is surjective or surjection or onto if every element of the codomain is the image of at least one element from the domain. So the way I think of surjective is that the range hits the entire codomain. So the range of the function is the codomain. That is a surjective function. A bijection is a function which is both an injection and a surjection. So meaning that the function hits all of the codomain, the range is the entire codomain, and the function hits each element in the codomain exactly once, meaning that's injective. The image of an element, here, let me move this up a little bit. The image of an element x in the domain is the element y in the codomain that x is mapped to. That is, the image of x under f is f of x. And so f of x, keep in mind, is not a function, it's an output. It's specifically the output when you plug in x into f. So if f of x is not the function, what is the function? The function name is f. X is the input, and f of x is the output. And sometimes we use y to represent that output. The complete inverse image of an element y in the codomain, written f inverse y, is the set of all elements in the domain which are assigned to y by the function. It's really important to understand and remember that the inverse function might not exist. However, in this context, f inverse y always exists, and it is exactly the set of all inputs that map to y. The image of a subset A of the domain is the set f of A. So in this case, that capital A is not just an input, it's a set of inputs, and f of A is a set of outputs, namely f of A, all the f of A in y is the codomain, such that A is in capital A, big set A. The inverse image of a subset B of the codomain is the set f inverse B equals x in x such that f of x is in B. So again, the inverse might not exist in terms of what you learned in like pre-calculus or calculus. However, this always does exist, regardless of what the function is. F inverse B always exists. In this case, we're not plugging an element into the inverse function. We're actually constructing a set by asking, what are all the inputs that map to the elements of B? Not just one element, but all the elements in B. Anyways, that's the list of all the notations and definitions and concepts within the context of functions. Thanks, everyone, and I'll see you in the next video.